Ah. So we're recording now. Let's go on to this one. We have a pulley, and we have two masses. So far, we have had systems that required a pull force. Every one of the systems to date, examples 1 through 7, always had a pull force. The vertical ones that we did were against gravity. The horizontal ones were against friction or just its own inertia. Now we have a system without a pull force. So a 4 kilogram block, which is M1, so I'll write down 4 kilograms here just so I know that's it, and a 6 kilogram block are connected by a rope that's over top of a frictionless, massless pulley. Draw both free body diagrams and find the acceleration of the blocks and the tension force. There's no friction. So let's get ready to draw the free body diagrams. This is free body diagram for the M1. And I will draw a free body diagram for the M2. Notice the container boxes are different. I do that intentionally to inspire you to draw the free body diagrams differently. FBD of M1, and this is the 4 kilogram object. And this is M2's FBD, and this is a 6 kilogram object. So let's at least draw the ropes that are on both of them. This is the tension force on this one. And this is the backwards tension force on that one. Those are the internal rope internal forces. On both of them there's gravity acting, so we're going to put gravity pulling down on them. There's only one on a surface. And there's no friction. If we had friction, we'd be drawing it on M1. Okay. Do I want to change it? No, I don't. What happened there? I don't know. So let's work with the system right now. The system has a mass of 10 kilograms. And the forces that are acting on the system. Okay, this is different where this is the direction of motion, but now this one is the direction of motion this way. So we have to kind of look at it that this only has a tension, that only has a tension and a force of gravity. So the sum of the forces, there's only one. The tensions cancel out. So it is the force of gravity of the 6 kilogram object. I'll just put it there. It's not the force of gravity of the whole system this time. It's just the force of gravity of that object, which is going to equal M6, the 6 kilogram object, times G, which is 6 kilograms times 9.8. So all the forces that are acting to move it is 58.8 newtons. That's 6 times 9.8. So let's draw out Newton's second law now. We got some of the numbers. The sum of the forces is our net force, which equals MA. Putting the numbers in, this is 58.8. MA. We're talking about the system here, so it has to be the mass of the system. And the mass of the system is 10 kilograms. A is therefore going to be 5.88 meters per second squared. That is the answer for the acceleration, so I box that off. Now, it's hard to say what the direction is with a word. Is it right or is it down? It's both. It's this way in this object, that's the acceleration, and it's this way in that one. So if you don't give me a direction, I'm fine. You can draw it like with the little A's there that I've done. It's just letting the teacher or whoever's marking it understand what you're doing. Now let's analyze these two boxes. Okay, so we'll deal with M1 here. We'll write out Newton's second law. The sum of the forces, use the net force, which equals MA. Question over in the corner.
Why does M1 affect the acceleration with friction?
Can I answer that once I finish these two free body diagram ones? It's an excellent question, but I will talk about that once I get the numbers, and then you'll understand it. There's only one force acting to move this one. It's the tension. The tension is equal to the mass times the acceleration. Please have that step. You need that step. It's the applied Newton's second law. So tension is going to be the mass of this object, 4 kilograms, times the acceleration. That's 5.88 meters per second squared. So Mr. Texas Instruments tells us that 4 times 5.88 is 23.52. That was a good answer. We do have to calculate the tension because, number one, the question asks us to calculate the tension. We ignore the tension when we're doing the system because as a system, the tensions are an internal force. They push and pull, and they end up canceling each other out. But with each object, we have to look at it.
So there's no FG1 and FG2?
There's no force of gravity in number one here that's in the direction of motion. So they will cancel each other out, the normal and the force of gravity balance. We'll do M2 here as a check. So we're going to solve for T again. So we'll write down Newton's second law. The sum of the forces equals F net, which equals MA. And the forces acting on M2 here is Fg and T. Fg is winning. The force of gravity on this object minus the tension is equal to the mass times the acceleration. Please have that step. Now you plug in the numbers, except for the T. Okay, so the force of gravity on this object is 58.8. That's the mg of this. Newtons. Minus the tension is equal to the mass of the object, which is 6 kilograms, times the acceleration, 5.88 meters per second squared. So tension here, by this calculation, is going to equal 58.8 newtons. Subtract 6 times 5.88. So the 5.88 times the 6 That's this number, 35.28. So we go 58.8, subtract that. So 58.8, subtract that answer. And we get 23.52. Celebration. How do I celebrate? Couple check marks that are checked off.